On behalf of Sri Chandrasekharendra Saraswati Vishwamaha Vidyalaya Kanchipuram, it's my great pleasure to welcome you all to today's session 12 of our one-week faculty development program. We are honored to have with us Mr. Rajesh Kumar, Plant in Charge BOMS Private Limited, Jhansi, who will be delivering his talk on modeling a resilient smart grid to combat the effects of climate change. Reliable electricity is a backbone of economic and social development, but climate change has made our energy systems increasingly vulnerable to extreme weather events, supply disruptions, and rising demands. Smart grids, with their resilience, adaptability, and ability to integrate renewable energy, represent the future of sustainable energy infrastructure. With his expertise in plant operations and practical experience in the power sector, Mr. Rajesh Kumar will provide us with valuable insights on how resilient smart grid models can ensure reliability, improve efficiency, and support climate mitigation. His talk will also highlight the role of AI, machine learning, cybersecurity, and case studies from across the world that demonstrates real-world applications. We are indeed privileged to have him with us today, and I am certain that his session will inspire and enrich all of us. With great pleasure, I now invite Mr. Rajesh Kumar to take over the session. Sir, the session is yours.
Thank you, ma'am. Thank you all. First of all, I want to thank Anisha ma'am to just ask. Last 2 months back, she asked to deliver a lecture on renewable energy. And I have chosen this topic, modeling a resilient smart grid to combat climate change effect. So I am honored by the opportunity to share my insight views on my topic, modeling a resilient smart grid to combat climate change effects. Once again, I thank to SCSVMV team and all the faculty members who has given me this opportunity to share my knowledge and views on this topic. Thank you, ma'am. Thank you once again to all the faculty members of SCSVMV.
Welcome, Rajesh sir. I am Lakshmi Bai.
Yeah, don't tell me, sir, ma'am, because I'm an alumni of this university itself. So I'm just in a learning phase, and what I have learned after passing from there, I will share that.
Definitely. Thank you. Thank you.
Thank you. So I will start my.
Yes, yes. You can share your slides, please.
Yeah. It is visible, ma'am.
Yes,
Yes,
yes.
sir.
It's
Yeah.
visible.
Just a minute. Now, first I will start with two famous quote for before I'm going inside my topic. So one famous quote is that electricity can transform people's life, not just economically, but also socially. This one said by our minister, Ms. Sri Piyush Goyal, Minister of Commerce and Industry. And we know that by the words itself, we can say that electricity, in every time we need electricity, whether from starting day starts to day stop. So everyone is agree on this one. So, and next, I want to share you one famous quote from Barack Obama, former US president. We are the first generation to feel the full effect of climate change and the last generation that can do something about it. It is very true that we are the first generation who are seeing this impact of climate on our system just now in hilly areas. Day by day, you are seeing the news that in that area some landslide is occurring, some other area cloud burst is coming. So we are seeing every day in our life, we are seeing climate change effects. So if we will not do anything regarding this, we would be with the last generation to see this one. So next I will go in my topic introduction. These things we will see in our session, this one, like reliable electricity is vital for economic and social development, which has been already discussed in previous slide. Power generation is major source of greenhouse gas emission and vulnerable to climate impacts. Like power generation means thermal power and all that. It is the major source of greenhouse gas emission. And developing countries face challenge rising demand, full import dependence, limited access, weak infrastructure. Energy efficiency and renewable energy reduce emission and building resilience. Integrated planning aligns development, mitigation, and resilience goals. Now, the challenge of climate change. Why we are talking about this one? That the growing threat to energy infrastructure. This is the major growing threat to energy infrastructure, because you have seen in many conditions like extreme weather events like heat waves, storms, floods, cloud burst, landslides, all these resulting in power disruption to our states and all, in states also and country also. So you can see this one, and traditional grids which were built is unable to handle this disruption, leading to outages and blackouts. You have seen many at many places that power cuts is there, outage for longer time, some maintenance work is always going on. So these traditional grids are not up to that much. So during some climate change, it is not that much reliable. Fluctuating weather patterns create instability for renewable energy source like solar and wind. Means that now a weather prediction, that much weather prediction is not. Are you getting my voice, ma'am?
Yes,
Yeah, sure.
it's audible.
Yeah, audible. The major impact will be on solar and wind due to some fluctuating weather condition, because if cloud is coming, yeah, prolonged rain is going on in some areas, that solar was affected in those areas. If wind is blowing too fast or too slow, then wind power is getting affected. So all these conditions are getting due to climate change, and every day we are having some threat to our energy infrastructure due to landslide or due to thunderstorm or due to extreme weather condition. Our day by day some power infrastructure is getting uh, hampered, or some sort of things were going on. So every day it is happening. Now power sector climate change, what are the vulnerability we can get due to some power, due to climate change, like temperature change, water availability, wind speed, flood and sea level. If there is a change in flood or sea level, what will be the condition? Extreme climatic condition means landslide or flood, flash flood, glacial lake outburst. Like these things are happening in hilly areas in Himalayan region. So, and everywhere some power sector is getting. Just a second, ma'am. I will. So power sector are getting affected by this climate change vulnerability. Now I'll discuss one by one with what are the things going on. Temperature change. Due to temperature change, most of our generation will be hampered in thermal power, hydropower, solar PV, biopower, and transmission and distribution demand will also increase. Like temperature will increase means we need cooling. We will start ACs, cooler and all that. So our demand will increase. What are the potential impact at that time due to temperature change? That one, crop will be damaged, irrigation, in irrigation, water demand will be increased. So, and due to that, generation capacity and operational change, reduced generation capacity. You know that due to rise in temperature, our solar operation generation efficiency will go down. Transmission efficiency and capacity also go down due to rise in temperature. Increased demand for cooling. Next, water availability. The most affected sector with water availability will be the hydropower. And then thermal power, because thermal power for cooling, they need water. Hydropower is totally dependent upon water availability only. If water availability goes down or goes very high, then its impact will be more. So if water availability go down, we cannot generate our plant on rated output. We have to reduce our output also. And due on climate means potential impact of this one, the crop will be reduced, decrease in crop production because water will be less, reduced generation capacity of a power plant, reduced generation capacity of thermal also. The change in wind speed, the most affected sector will be wind and its generation will reduce due to low wind speed. Due to high wind speed, it is more chance to get wind power station, it will get burnt due to high speed of wind. Flood and sea level. If there is a rise in flood sea level, then flood will come and it will mostly affected the sea areas, cities which is near to seas, and in that areas the power company will be affected. Power generating companies will be affected by those things. And physical damage, if flood will be there, then physical damage of powerhouse is going, can be noticed very extreme climatic condition. It is same like that. Every power sector of will be get affected with this one. Transmission and distribution will be also affected, and physical damage to powerhouse will be there. Reduced transmission capacity, increased peak electricity demand. Now I will show you some photos of powerhouse which has been damaged during landslide or cloud burst or flash flood. This is Malana HEP in Himachal Pradesh, July 2022. Before in Jhansi, I was worked there, and due to cloud burst and landslide, this the whole switchyard of this power plant has been washed away. Now we are proposing for GIS for the same power plant. The next is Retale HEP J&K, Jammu and Kashmir. Here also landslide has damages some portion of powerhouse. Subhansri Lower Hydroelectric Project, Arunachal, due to flash flood, all the dam gates were get affected. Kopali HEP, Assam, you can see from there, flash flood is coming, and all the transformer deck was affected by this one. Next, Tista 5 HEP, landslide has been occurred near the switchyard, Sikkim. And this one penstock got ruptured due to landslide. Tungabhadra Dam, Karnataka, and due to heavy flood, its gate got damaged. Mahan 3 HEP, Chhattisgarh, the whole powerhouse has been flooded due to flash flood. This one is Tista 3 Dam on 4th October 2023. Clough has been taken, Glacier Lake outburst flood. Due to that flood, the whole dam was breached and washed away. In this power plant also, I have worked from 2017 to 2020. After that, I came to Jhansi itself. Now, due to wind effect, this windmill or windmill blades will got affected. So these are the effects of climate on power system. Before going to next slide, I just want to ask you that any question till now?
Participants, any questions from you?
We can have the question sessions at the end.
Okay, right, ma'am.
Okay.
Okay. Now with weather prediction, we are not that much sure about our weather prediction. So nowadays, with the help of AI or machine learning programming, we are doing some weather prediction, like numerical weather prediction. Traditional physical models were not up to that mark. So now, with the help of AI and machine learning, we are predicting our weather. We are predicting our weather so that we can get accurate data, whether the rain will be occurred, whether cloud burst will be there or heavy rainfall will occur like flood. We can also with AI learning and with AI and machine learning, we can note it down with the areas of with high wind pressure or like that. Everything we can getting nowadays on our mobile itself with the help of this AI and machine learning. So nowadays weather prediction is somewhat easy with the help of AI and machine learning that I have shown in these two slides. These are the models: numerical weather prediction models, statistical models, hybrid models. These models are now it is being used with to predict our weather, so that we can reduce our damage to our power system or power infrastructure. What I have talked like the game changer means with AI and machine learning, we can forecast our weather at easy. We can forecast and we can use it. Application. We can know that weather can be forecasted, but what will be the application of that weather forecasting? So based upon that weather forecasting, we can forecast our load, that if in any area there is rise in temperature, means cooling demand will be there. There will be demand will be more than from consumers. So in those areas, generators should work at more efficient or more output. So we can predict all these load condition, grid load forecasting we can do with the AI learning. And you can know that we are scheduling 2 or 3 days before to our generators that this much generation you have to do. Likewise, demand also has been forecasted that this much is demand for the next day or very next day. So like this, the balance will be maintained in our grid generation and distribution. Now we will talk about resilience theory in our power system. What will be the resilience theory? Because core idea, ability of system to adapt and maintain functionality during disturbance. If any disturbance will come, like with extreme weather condition or blackouts or something, then our system will have ability to maintain load and demand that time. Due to disturbance, it should not get affected. Draws from ecology, psychology, complexity science, means it should be helpful for our ecosystem also. Key principles of this resilient system should be adaptability, redundancy, learning. Means any condition will change, then the system should adapt according to that condition. Every time backup should be there. It should be robust, adapt and recover, flexible and multifunctional. Important thing, why important for power system? Because our power system is complex and interconnected. So every day there will be a climate risk, and accurate risk assessment is very difficult. So we need a resilient system that can combat with our climate change. So why resilient power system required? Same thing. It should be safe, secure, because we need reliable, safe and secure electricity. Greenhouse gas emission reduction we need to mitigate climate change. Economic and social development represents cross-sectoral growth and resilience. Now, resilient system trapezoidal curve. In this figure, you can see that there is three stages: stage 1, stage 2, stage 3. Stage 1 is a disturbance progress state. Stage 2 is post disturbance degraded state. Stage 3 is recovery and post restoration stage. Now, before you can see that pre-disturbance state R0. At R0, the system starts at a stable resilience level R0. This is a baseline, a robust, a resistance of the system before any event occurs. Means there is everything is normal. Now, nothing has been happened. Event strikes T0E, you can see. This may be due to some natural disaster, equipment failure, or cyber attack in terms of a smart grid. So this drop continues until the end of the event, means this resourcefulness, redundancy, adaptive organization. The lowest resilience level is denoted as RPD. It will come down up to RPD. This stage reflects the system robustness or resistance, how well it stands the disturbance. It means like that. Stage 2, after the event ends, the system is in a degraded condition. Means now system is somewhat in degraded condition. Resilient system stays at low reduced level for a while. This time the ability to adapt, reorganize and use redundant source like battery storage system or some other system to help it out, to helps or prevent full or total collapse. Otherwise, our grid will collapse if we will not get a backup at this time. Stage 3, recovery stage. In that stage, it starts at time TRT and its restoration is initiated. Means backup. Now backup we are getting backup. We are getting backup. So it will go gradually. It will start recovering. Recovery phase, partial recovery state means we are getting some partial recovery itself with some backup plan. So at full restoration, it means that the damaged infrastructure of power system has come into service, and that will be the full full restoration or recovery state. This trapezoid highlights the lost resilience area, the gap between pre-disturbance resilience and degraded state during disruption and recovery. By this trapezoidal, we can measure how quickly our system can be recovered, or design a strategy to reduce degradation depth. If degradation depth, here you can see that if we don't know the degradation depth, our system will collapse. So by this trapezoidal curve, we can know that at any disruption, our power system, at what state it can go down. Before fully collapse, we can start recovery of that power system. Next, for this technical solution, what are the solution for this energy efficiency and renewable energy to support resilient power system? This is the technical solution for this one. Scaling up energy efficiency, diversifying generation portfolios, deploying distributed generation, enabling a storage solution, developing a smart grid using grid enhancement technologies. Now, integrated planning, energy efficient planning. Demand side management, energy efficient building code. So we can combine energy efficient devices. We can integrate renewable energy, a storage system, and a smart grid into one strategy to combat these things. Aligns energy solution with national priorities, ensure cost effectiveness and long-term resilience, support both development and climate goals. Now in demand side management, strategy to control and optimize our electricity demand. Shift uses away from peak hours to reduce strain on the grid. Encourage energy saving through smart meter pricing and automations. Improves grid reliability and support integration of renewables energy. Energy efficient building code set mandatory design and construction standards so that our demand should be low as of now. Nowadays, buildings are building up with building codes in that lighting load is not that much due to use of glass, special glass type, or cooling system is designed in such a way that AC load will be reduced. Reduce energy consumption in building. Lower cost emission over the building's lifetime. The building design should be like that. It should be built in low cost, but carbon emission and all that should be low. And it also support climate change, or it is resilient to climate change, sustainable urban growth. mixture of renewable energy like solar, wind, hydro, bioenergy, and low carbon sources. We have to reduce our dependency on single fuel or technology like thermal. We have to depend upon coal, and for most of the thermal plant they are importing coal from other country. So we have to reduce that dependency also. Enhance grid stability and energy security. Due to diversifying portfolios, we can get this grid stability, because in some other areas something is going on. So other areas, wind or solar or hydro can boost that grid demand. Mitigates risks from climate impact and price fluctuation. Due to renewable energy, we can mitigate that climate impacts, and price also for generation it can be reduced due to integration of renewable energy. Deploying distributed generation means generation at a small scales, like rooftop solar in our home itself, or in industry also we are focusing to get rooftop solar, mini grids, wind also we can adopt. And it should be nowadays you can see that generating power station is almost located far from the city. So its transmission loss is getting affected. If we are having distributed generation nearby our city, the transmission cost will be reduced and we will get electricity at low price. This enhance our grid resilience during any outages or disaster. Battery energy storage system is also a way to combat this climate change. And in real time, we can supply the electricity from our battery energy storage system. And it also supports renewable integration like solar and wind. If we are having battery energy storage system, we can charge those battery from our solar system or wind energy, rather than energy we can take from our grid. It provides backup power and enhanced grid resilience. Means in any power disruption, in grid disruption, if demand is high and we cannot generate that much, so we will use this backup power as to meet out our demand. Now integration of GT, grid enhancement technology. DLR is there. DLR is dynamic line rating. It is a real time data of weather data or FACTS is there, flexible AC transmission system. Topology optimization powered by AI, integration of ADMS with SCADA, a smart grid with AMI proactive response, outage and energy forecasting with help of AI or machine learning, demand side management, that is demand response, or PMU analysis with AI. Now I will one by one, I will explain what it means, DLR and all that. DLR means dynamic line rating. By this we can get a real-time data of transmission line based on actual operating and environmental condition. Means we are not getting only the power data like kilowatt or voltage or kVr, MVR. We will also get the temperature, wind speed, solar radiation, all these parameters with DLR so that we can manage our transmission line in a better way, depending upon the real-time data of climate. Due to that, there will be a benefit increase in transmission capacity and efficiency. It can reduce congestion and enhance situational awareness. If temperature is high, we can know that there may be a heat wave or sudden wind speed sudden increased, then we know that there will be wind storm or like that. We can know everything with this DLR, not only the power data, but also the real-time weather data also we can know by this DLR. Facts, flexible AC transmission system. These are the power electronic based system designed to improve the controllability and increase the power transfer capacity of AC transmission networks. It plays a vital role in reliability, stability, flexibility, and efficiency of power system. Topology optimization powered by AI. It is network configuration data we can get from this one, optimize power flow path, reduce losses and operational cost, enhance flexibility in grid management. By this, we can know that whether demand will whether demand is varying or like that, we can know the real situation with these things. ADMS and Advanced Distribution Management System is known as ADMS with a integration of ADMS and SCADA system. We can predict the load, power load on our substation or remote shutdown if anything happened. Real-time grid monitoring we can do with this one. Fault detection we can do with this one. If anything happened, we can get a message through on SCADA that something has happened to that line or some grid or to some substation. Smart grid with AMI for proactive response, real-time power consumption, fault detection, and historical hurricane data. We can predict vulnerability, reroute our power load reduction, targeted shutdown. These we can get through this one. Outage and energy forecasting, which as we have discussed earlier also. Accurate forecasting of electricity demand and supply, predict and prevent equipment failures. With demand side management and response, with this we can get some smart meter data we required, user preferences we required, so that we can get a demand side management. DLR, load shedding during peak demand. If our demand is more in during our peak, so we can do some load settings to improve our grid stability. PMU analysis with AI. Phasor measurement unit. It measures voltage, currents, phasors, magnitude or angle of the current, frequency and rate of change of frequency with GPS tamping. With this, we can get the real time grid monitoring, detect integration of renewable energy. The positive effects of renewable energy on power resilience and better response to various threats. I have mentioned all 3 to 4 points on renewable energy benefits. The renewable energy generation. And with this adjustable and dispatchable generation such as energy storage system, pump storage or distributed small capacity gas turbine shall be planned and installed with fast control and protection system. Large capacity renewable energy shall be carefully evaluated from the grid point of view before the connection. The capacity of related distribution line and substation shall be verified and strengthened if required. The site for the construction of renewable energy shall be carefully selected considering the impact of health events based on finding of a detailed location specific climate and disaster risk assessment. We need to choose our site very carefully so that in any climatic changes or due to some extreme climate change, it should not get affected. Now we will come upon a smart grid. Smart grids are also known as self-healing and self-adapting grids. Automated objective analysis and correlation of various types of event even enable the utilities to proactively respond to feeder events rather than merely being able to react to them. Now, the benefits of smart grid. It is intelligent, capable of sensing system overload and rerouting power to prevent or minimize a potential outage of working autonomously when condition require resolution faster than human can respond. In any condition, it can respond very fast and it is by self it can do. Nowadays, now in present time, we humans have to respond on this one, that overload should be get disconnected or load shedding should be done. But through a smart grid, it can be done by a smart grid itself, based upon AI or machine learning programs, what we are feeding to the program, it will react on that only. So it is more efficient than nowadays. The grid is accommodating accepting energy from virtual any fuel source, including solar and wind. It can accommodate any type of generation power generating source like solar, thermal, wind, and hydro, gas. All these things can be accommodated on a single bus. And it is a real-time communication between the consumer and the utility. A smart grid can provide us the real-time communication between the consumer and the utility, so that we can tailor our energy consumption based upon individual preferences, price, and or environmental concern. Next, this one, opportunistic, creating new opportunity and market by means of its ability to capitalize, plug and play innovation wherever and whenever appropriate. Quality focused, capable of delivering the power quality necessary, free of sags, spikes, disturbance, and interruption to power our increasingly digital economy and the data centers, computers, and electronics necessary to make it run. Resistant to attack and natural disaster as it becomes more decentralized and reinforced with smart grid security protocols. Green, slowing the advance of global climate change and offering a genuine path towards significant environmental improvement. Now we will come to conceptual smart grid design. This diagram show you the conceptual smart grid design. Here it is a main grid, then point of common coupling, where then controller and energy management system, intermittent variable generation from solar, rooftop, or wind, or hydro turbines, or anything, any interruptible load, critical load, non-critical load, and dispatch generation center. Storage system like a battery storage system, grid stability and time shifting, electric vehicles, mobile storage, hydrogen bulk storage, long-term time shifting blend with biogas and natural gas, thermal storage coupled to organic Rankine cycle generator, and HVAC system. Another, this one is the conceptual smart grid design. In this one, you can see that management system for generation and transmission supervisory management, which is connected through wide area network, and all generation utilities is connected with this one. And you can see that red line is showing power network and blue line is showing communication network. After that, ICT, distribution and microgrid control. In this one, transmission, intelligent substation, distribution automation should be connected. And with this one, EV and charging station will be connected. DG and diesel generator and microgrid also connected to this one, and energy storage system is also connected to this one. Next, we will add consumer side management that will be connected to home area network or LAN. Here it will be residential complex or industrial. And we can also have our small grid like a rooftop solar or a battery energy storage system. We can also use, which was set up upon our residential or industrial, we can use here itself. Now we will talk about AI and machine learning in smart grid resilience. With AI, we will get in AI, we will put the customer and service center notified outages, debates, collects feedback and meter data. We will put all this data into AI so that we can know the customer and customer demand, that what are its need. In planning and engineering, we can give with help of grid data, we can make a resilience strategy so that our system should be resilient in any weather condition. Smart grid application, in that one we can use our AI to predictive maintenance or detection or self-healing and load optimization. We can use of AI and machine learning. Grid control operations. In grid control operation, we can, with the help of AI, we can know the fault localization. Grid we can reconfigure to one way to another way. Event logging. If anything is going in grid, we can log the event, and based upon the event, we can take our steps. Dispatch and maintenance, with AI tools, we can know the automated repair dispatch means with AI, if maintenance required, we can repair it with the help of AI itself. Grid restoration. In grid restoration also, AI can help us. Circuit breaker monitoring on, off or anything, it can be taken care by AI. So smart grid, basically a smart grid is a power grid plus information and communication technology with information and communication technology. A smart grid uses a digital technology to improve its reliability, security, and efficiency, both economically and energy of the electrical system, from large generation through the delivery system to electricity consumers, and a growing number of distributed generation and storage resource. ICT are a core of successful smart grid implementation. Without information technology, we cannot implement our smart grid, and its reliability, security, all will be affected if we don't have a good information and communication technology. More connectivity means information, IT and communication technology. If we are having greater connectivity, we will have a high exposure to cyber and physical threats. Secure, resilient design is essential for preventing disruption. If cyber attack will be there, then we need a secure and resilient design to prevent it. To prevent it. These are the smart grid architecture. You can see that grid is having generation, transmission, and distribution at customer in smart appliances, EVs, HVAC. Service providers are operators, markets, smart metering, reading control and maintenance, communication network, IP, telecom, functional domain, AMI, WAMPAC, DGM, demand response, and SCADA. With a smart grid, we are having a challenge to cyber security because nowadays, if we are connected with networks, means any network, mobile network or information technology network, so we have a threat of cyber security, and this can totally collapse our smart grid or any grid. In recent time, you have seen that in Ukraine, one of the power plants got shut down by Russia itself due to cyber attack. So these things can be happen in future also. So smart grid cybersecurity is a big challenge for us to maintain the smart grid operational on performance, its reliability, and its availability. So everything has to be secure with the cyber security and its threat. Layers of cyber security is there. So one by one, I will discuss. These are the human layer, peoples and awareness. This is the first and weakest link in cyber security. We need to aware our people not to click on phishing emails like that, or some smart grid operator. We need to give training so that email which has been which is coming to our powerhouse or powerhouse control room operator system. So we need to check all these things. Otherwise, any email which is containing virus or something, it will get affect the power plant. So we can be very careful while opening email and all that. If we don't have any cyber security with our IT or OT networks, we will be in a great threat and our system will get collapse if anything will be happen or any attack, cyber attack will be done. So in our powerhouse also, we are trying to maintain that our IT network and OT network should have different network topology, so that virus of IT computers should not go to OT, means operation technology computers, which like SCADA we are operating or we are doing, and we are prohibited use of pen drives and other things. We have blocked some sites so that it should not get virus in that one. And in SCADA, we have fully stopped the use of IT, means using of internet in that system. Next one is perimeter security layer, which protects entry and exit points of the system, like firewalls, intrusion detection, prevention system, VPN address, all these should be secure and should not be, it should kept confidential and should not be shared with anyone. Unauthorized access to control centers. Only in our powerhouse also we are trying to maintain that only authorized person are getting entry to restricted areas, like where we are keeping our servers, where we are keeping our IoT networks servers and systems, so that only authorized engineers are allowed to enter in those areas. Next one is network layer. Protects internal network traffic. Segmentation of IT versus OT networks, what I have told you earlier itself. Monitoring zero trust networking. SCADA from corporate and IT networks. Endpoint security layer protects, it means that protects our computers, servers, smart meters, and all that. Antivirus and patch management system should be there. And in our powerhouse, every system is having antivirus, and it should be updated based upon new cyber threat. So every 4 to 5 years, we need to get checked through our cyber security team. And for this, we are hiring cyber security experts from cyber security, so that they can check the vulnerability test and they can perform vulnerability test on our system, IT and OT networks, so that other cannot come inside our network or anything it cannot do. Application layer means our software, it secures our software application, like a SCADA software, ADMS software, AMI or billing software. Data layer protects our data and transmitted data. It should be confidential and available anytime. Mission critical layer ensure continuity of operation under attack. Any attack, it should be operational, and there should be a redundancy system should be there. Automatic fail over to backup control center in case of cyber attack on grid or SCADA. So these are the 7 layers of cyber security which I have mentioned here. Security objectives for a smart grid. It should be confidential, integrity, and always available. Resilience, the ability to recover quickly from any attack, and privacy, protecting personally identity. The information should be identified. Types of attack. There are 2 types of major. We are having 2 types of attacks, cyber attacks: external threats, nation or cyber criminals or organized crimes they are doing. Like I have told you that in Ukraine, Russia has done. That is external threat, and internal threat will be our employees itself or insider threat. Maybe some employees can inject a virus through use of pen drive, or they can use some sites on IT networks. So for that, this type of attack is there. And some other attack, like denial of service attack. This attack is also known as DOS attack. in this one, attacker used to flood some packets, means it's like a network jam. In server are getting overloaded with this one, and we in real time we could not operate our power system like that through a SCADA or through anything. We could not able to operate our power system, our power plant, our generators. So this type of jam is known as denial of service attack. Then random attack. Then there is a false data injection attack. Some attacker, what they are doing, that they will inject some false data. They can change the data of our plant, and in real time operation it will get affected. If generator need to synchronize at 428 RPM and some attacker changed to some 400 RPM or more than 428 RPM, so it will get affected. Our machine will get affected due to high speed. So likewise, this type of attack can be done through cyber attack. Malware also is there. In this one, attacker can introduce malicious code into the system, which can cause damage. So threat landscape in smart grid. First of all, advanced metering infrastructure, AIMI, unable to physical tampering and password exploit. Weak encryption exposes data and control signals. BAMPAC is prone to DOS and data injection attack. Distribution grid management attacks on in-field devices and wireless network. SCADA software bugs, insecure links, and malware inspections. Demand response signal spoofing, denial of service risk. These are the threats associated with the smart grids and its. What are the techniques we will adopt while we will come under cyber attacks? With first method is a lightweight message authentication method. It is used to secure a smart grid system where distributed meters are mutually authenticated. Means authentication message, if we are trying to log in, so we need a authentication message that somebody is getting log into your system, and like that. By using supervised learning algorithm, the generalized likelihood radio detected test technique is there, in which we are having two model system, and we can itself do a statistical test and compare whether the model is working as per our requirement or not. If any model is not working, means that model is come under cyber attacks. So like that we are doing detecting cyber attacks. There is a security guidelines and best practices for our power system, and it is saying that layered security models apply to that. What I have told you, 7-layered security model should be there. Risk-based assessment for vulnerabilities and threat, authentication, patch management, and intrusion detection should be there. Best practices, authentication and access control. Use role-based access control and strong authentication for users and device. It means that for every hierarchy, we have fixed some authentication method that for engineers, we have this much level we can do. For the maintenance engineer, they can change our algorithms or the steps associated with operations and like that. So for everything, every hierarchy, we are having some access-based control so that they cannot access upper hierarchy system. Otherwise, if a technician access the code of maintenance engineer, and it has modified some data or some steps without knowing the cause of that changing, it will lead to a great disaster. So based upon access and hierarchy, we are giving this access to our team. In our our powerhouse also is SCADA having 3 layered security, and one for general for supervision, second one for engineers, and third one for modifications. So we are doing like this one, and regular audits. In our powerhouse also we are doing regularly audits all these vulnerabilities and all that. We are using we are giving training to our employees and personnel to how cyber attack can affect our power plant operation and all that. So every 3 to 4 months we are having a particular training on cyber security itself and leading to power sector and all that. So we are giving every employer training on this one, those who are working on SCADA or IT or OT networks. Now I'll be talking about some case studies, how a smart grid helps us in climate mitigation and all that. First one is wild polarized microgrid Germany. The microgrid it has been, the system generates over 500 of the village electricity needs and has created significant revenue for the community. With the effect, these are the wind turbines we are talking about, and ma'am, you are getting my voice?
Yes, sir. Yes,
Yeah,
Rajesh.
yeah, ma'am, because the network is very slow here.
Ah, 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 ah. Almost the time is nearing.
Yeah, yeah.
Okay.
Next one, Yokohama Smart City, Japan. So here we on every house you can see that solar panel has been fitted, and it's about 27 megawatt solar power is there, and this reduced by implementation of this, it has been during peak demand power has been reduced by using this one. So we are having some demand side management also we have done. Now in India, we are having Puducherry Smart Grid pilot projects. It has climate resilience impact was loss reduction. The project significantly reduced aggregate technical and commercial losses, AT and C losses by allowing real-time monitoring and minimizing theft and inefficiencies. Renewable integration, it demonstrated successful integration of distributed renewable generation, including rooftop solar, showing outage management also has been done with the help of this smart grid pilot project. Last microgrid in rural India and Ladakh. In Ladakh, we are also using solar energy to combat our climate change, and with the help of these solar panels, we are charging our battery energy storage system, and in any blackout or outage, we can use this battery energy storage system for our power system. That's all from my side, ma'am. Thank you. And
Thank you so much, Rajesh.
thank you,
And
ma'am.
participants,
Any
please
question?
ask your queries.
Ma'am, I will be back in just a minute.
Okay. Participants, if you are having any queries, please type in the chat box, or otherwise, you can raise your hand. You will be given mic.
Yes, ma'am. Yes. Actually, ma'am, network is very slow here, and I think my voice was not that much clear.
No
No, it
issue.
is clear only.
Clear.
No, that time during presentation, because sometimes it got muted. Our net in powerhouse, our network is slow because today is raining outside.
Okay, okay.
Okay, it's any question, ma'am?
Sir, in traditional grids, were these and all were not designed for high renewable penetration.
Yes.
You mentioned smart grids also. How can smart grids help balance reliability with the variability of solar and wind energy?
Yeah, ma'am, small grids like we are talking about the solar system installed on our house or premises, industrial premises. So it is not directly connected to main grid. It what we are connected on for LT side itself. In our powerhouse also we have connected on LT sites. In UP it is not like that. We can do on main bus also we can connect, but for that we required a specific line, particular line. We can inject on our bus also if we are having solar on our industry. And while we are generating through our hydro generators, that solar will be injecting in our grid. So it's work like that hybrid models. Some guidelines has been provided before connecting to main bus, means load bus. So everything we are doing.
Okay, okay. In the Dhukwan project, your SHEP project, are there
Yeah.
any site-specific challenges you have faced while integrating smart grid concepts into a hydroelectric system?
Yeah, we are having, ma'am, because what we are talking about that we can directly connect to load bus. In UP, we are not getting that one. And what if we require that one means we have to give a specific out path, means a way to give power output way. So we required for that one transformer, means and then a particular to that particular bus we will connect that with rooftop solar we can connect through it. Now we are doing that, we are installing zero export device. By that, if we are not generating and we are not utilizing solar on fully, so means our capacity is 97 kilowatt, and during any day our capacity got means our demand reduced, which we are using inside our powerhouse, it got reduced. And due to high, good weather condition or good sunlight, we are generating about 90 kilowatt, but we are utilizing only 40 kilowatt. So other 50 kilowatt can go in main grid. But due to some UP's norms and condition, we are not giving to grid. We are just installing zero export device so that the generation could be 40 kilowatt depending upon our demand or itself, our powerhouse demand. We have given a letter to UPPTCL, UP Power Transmission Corporation Limited. We can get a chance to inject this extra power on no cost itself, but they are not agreeing on that one also. They require some specific way to get our power out from our bus. Like that they are doing.
Thank you so much, Rajesh.
Thank you.
Any questions from our audience, our participants, please? Is there any questions, please? You can post in this chat box, or you can ask unmuting your mic. So I think there is no doubts from participant side. So, as we conclude today's highly engaging session, it is my honor to deliver my thanks to Mr. Rajesh Kumar. First and foremost, I extend our heartfelt gratitude to Mr. Rajesh Kumar, plant in charge, BOMS Private Limited, Dhukwan SHEP, Jhansi, for sharing his knowledge and expertise with us on modeling a resilient smart grid to combat the effects of climate change. Rajesh, your talk has given us not only technical insights but also a vision of how resilient, intelligent, and green power system can be developed to withstand future challenges. I sincerely thank the management and organizers of this FTP at SCSVME Kanchipuram for making this learning platform possible. A special word of appreciation goes to all the participants and faculty members for their active involvement and thoughtful engagement during the session. Finally, I would also like to acknowledge the efforts of the technical and support team for ensuring the smooth and seamless conduct of this program. With that, we conclude today's second session. Thank you all once again.
Thank you. Thank you.
Now let we have a photo session.